Okay, so next we're going to talk about powers of diagonalizable matrices. So we're going to go back to the example that we started this section with. This time we're going to try and write out an expression for this matrix to the sixth power. So that means A times A times A, 6 copies of A multiplied together. The information we have are a set of eigenvector eigenvalue pairs. We have enough eigenvectors for a basis. Now, so one strategy is we could write down just the expression for A and then multiply 6 copies together. I think a more helpful thing to think about is what's happening to our eigenvectors. Okay. So if we think about what's going on here, let's start just by thinking about V1 until we get the picture. So we start out with this vector V1. When we calculate A times V1, our eigenvalue is 2. So that means that we double the length of this vector. So we get 2 V1. If we calculate A squared V1, okay, this is A times A V1. So again, we are going to double the length of our vector. So this is going to look like 2 squared times 1. So this will be 4 times the original length. Okay. And if we have A cubed V1, we get A times A squared V1. Or 2 times 2 squared times the vector 1, 1. So this is going to be 2 cubed times 1, 1. Okay. And hopefully we start to see this pattern that A to the K V1 here is going to be 2 to the K V1. So if applying our, if multiplying by our matrix stretches by a vector of 2, then taking a fourth power will multiply by 2 to the fourth. Similarly, if we have A to the K times V2, what's going to happen here? V2 is still an eigenvector. This time its eigenvalue, though, is going to be 1/3 to the K. So if we're taking A squared times V2, the eigenvalue is going to be 1/3 squared. So our eigenvalue here looks like 2 to the K and 1/3 to the K. All right, we still have the same set of eigenvectors though. So in this case, we're going to see our P matrix and P inverse are going to stay the same. So here our P matrix is 1, 1, 2, 1. Our diagonal matrix, our eigenvalues are 2 to the 6th, so 2, 4, 8, 16, 32, 64. And 1/3 to the 6th. And we'll have P inverse, which we had a determinant of -1, so this gave us -1, 2, 1, -1. P, this ends up being just d to the 6th times P inverse. We could leave it in this format, or we could multiply out. So we would get 64, 64. And then 2 times 1/3 to the 6th. 1 times 1/3 to the 6th. And take this product as well. What we can see here is that this second, the direction corresponding to the second eigenvector 2, 1 is going to fade away. It's going to go to 0, whereas the direction V1 is going to become very strong. All of our vectors are going to get quite large. So multiplying out here, we get negative 64 plus 2 times 1/3 to the 6th. Negative 64 plus 1/3 to the 6th. 64 times 2, so 128 minus 2 times 1/3 to the 6th. And 128 minus 1/3 to the 6th. Okay, and so in very few steps, we're able to produce this big power of a matrix. Very good. Excellent. And we didn't really have to sweat very much for this.